All right, welcome everybody. I'm Justin Cappos. I'm a professor at NYU. I'm also one of the creators of In-toto. And
hi everyone, my name is Alan. I'm a software engineer at a small company, and I'm a maintainer of In-toto.
So we're going to be talking to you a bit about In-toto and trying to give you a little bit of background and tell you a bit about it in case you don't know what it is. So first of all, we need to talk a little bit about software supply chain and software supply chain attacks. So there's lots of ways to define a software supply chain. I'm not going to read what's on the slide to you, but it's basically the process by which you make your software, the things that happen, whether these are machines that are going compiling things, whether they're human developers creating patches and stuff like this, whether it's your lawyer looking over a license to decide if they can take open source software. All of these types of things come together to become your software supply chain. And here's just a really simple example here where I have a version control system here. There's some testing that's done over it, like a linter is run directly on my source code. And then assuming that the linter is OK with it, then I might proceed to actually go and build the software and then package it and send it out. And real software supply chains will often have many more steps here, like I might do fuzzing, I might actually do some unit testing and stuff like this on it. I might be pulling in dependencies from other locations and stuff like this. But this is just a really simple example that fits nice on a slide, and I hope we can all kind of conceptually understand. OK, so we talked about what is a software supply chain. Now let's talk about a software supply chain attack. And this is a situation where a party goes in and causes something malicious to happen. And in fact, in some cases, it doesn't even require an external party. In some cases, it can be something accidental that occurs. But you end up with the process not proceeding and not behaving in the way that you would expect or desire it to happen. And there's tons and tons of incidents for this. So for instance, if we just look at version control systems here, there have been a bunch of really high-profile incidents where, in the case of one of them that I'll just happen to bring up, where allegedly the NSA broke into Juniper and put a backdoor in a lot of their products that let the allegedly NSA go and backdoor a whole bunch of Juniper VPN connections that were being made by any of their routers over an extended period of time. That's not an isolated incident. Once again, we could fill this whole talk with talking about lots of things that have happened. And there's a wonderful software supply chain catalog that exists under the CNCF, which lists 100 or so software supply chain, actually I think more than 100 software supply chain incidents, and describes where they occur and stuff. I'm just going to talk about some high-profile ones you might have heard of. In a build system, there have also been lots of incidents and compromises that have happened over and over and over again where attackers have gotten into this infrastructure and done malicious things. One of the most notable was what happened with SolarWinds, where, once again, allegedly Russian hackers this time broke in and put in backdoors that would have let them get into all sorts of Fortune 500 companies and parts of the US government and other high-profile networks like this. When it comes to sort of the packaging or distribution standpoint, there's also been lots and lots of different incidents of this. One incident was an incident where the Xcode library for Apple, which wasn't being natively distributed from fast local mirrors inside of China, where someone had put a malicious version up of the Xcode library that they said was just the faithful mirror of it in China, and a whole bunch of Chinese developers then downloaded this maliciously backdoored version of Xcode Ghost and ended up including this in software that they were creating and then distributing to others. So this is quite a nefarious attack. And finally, last but not least, I am going to be very nice to the CrowdStrike folks and not talk about them here. And I'll use another incident just to say that testing is also something that a lot of companies can get wrong. There was an incident, almost 10 years ago, where Microsoft accidentally pushed out an update only to a few mirrors, and those mirrors happened to serve countries like Kazakhstan that have repressive regimes that spy on their citizens and do things like this. So a lot of people were suspicious that Microsoft was putting a special backdoored version of its operating system out just so they could target dissidents in certain areas. Just to show that that was not the case, Microsoft accidentally did the same thing for other mirrors a couple weeks after this. and accidentally pushed a bad release out there. But this is, once again, not an isolated incident. Apple and other organizations, many of them have failed to correctly run their testing and have accidentally pushed out beta versions or things like that out into production, as I'm sure at least some of you in the room may have accidentally done from time to time as well. And I'll also say that attacks on software supply chain in general have been growing enormously over time. It has had this sort of exponential growth where people have been more and more tuned in and doing more and more attacks. I first started to work on software supply chain security back around 2002 or so. And in that time, like, almost no one was paying attention. When I first started to release and talk about problems then, I actually normally had people at sort of what would now be kind of the nation state actor hackers reaching out to me to learn more information. And for a long time, this was the domain where mostly nation state actors were doing really clever attacks to target infrastructure, to target, so that South Korea's banks and infrastructure would lose $750 million US in a cyber attack that allegedly came from North Korea, or you'd have power plants in Ukraine go offline allegedly from Russian hackers, or things like this. But it's really become much more mainstream, unfortunately, now, and is an issue that really everyone has to worry about, because attackers are increasingly going after things like the common package repositories we all use, and targeting more and more companies. So this brings me to a sharp detour in what I'm going to say, what about compliance, right? So I promise you it'll make sense why I'm talking about compliance in a second here. And there's a lot that now everyone has to do with respect to compliance. If you're in the US or other places, you have to do quite a bit with SBOMs due to an executive order that came out a while ago. There's the European Cyber Resilience Act, which has gone and further mandated certain controls and protections. And even in the UK largely has modeled what they're doing off of these existing regulations and the guidance that's come out of other organizations and other places, like the Secure Software Development Framework out of NIST and other publications that they've been involved in. And so what's kind of interesting here is that a lot of this compliance work, as we're about to hear more about, is actually going and causing us to put better controls in lots of places. And one of the main areas this happens is actually related to in-toto attestations in the software supply chain. So with that, I will hand it, So compliance is an enabler, and I really just said exactly this, that if we all, if we take people that are used to doing things like making sure something conforms to have certain properties, and we can add security into the process they're doing, then we can actually make security better at the same time while letting them still do compliance. So to talk more about that, Alan, why don't you take it away?
Yeah. Thank you, Justin. So I'm going to start by talking about how do you achieve this compliance with transparency, right? So first of all, let's look at examples of a supply chain, right? They can be very complicated, right? You have multiple steps within it. They can be located within a VPC. You can be calling another cloud provider. And within each instance, you then have multiple steps within it, right? So how do you then easily tell a government official that you are compliant with a regulation that you need to adhere to? So with that, I'm going to introduce to you like, hey, maybe you can do this via transparency, right? So what do you mean by transparency? Basically, using two sets of tools, one for information collection, the other one for basically information discovery. One of them is basically to collect all of the evidence that in the supply chain. So basically, hey, build data. I believe you have like package managers and SBOMs, and then once you have all this data, how do you make sense of it and how do you collect it, right? You don't want to just dump it up into like a big binary storage. You want to be able to access the things that you care about when you need them. And with that, I will then introduce you like basically how do you then make sense of all of the data you have, right? Since each program we know that creates its own standard, creates its own framework, and we introduced In-toto as basically a way to make everyone talk the same language, right? So basically, we want to make sure that, say, when you're downloading something from GitHub, it gives you the same attestation, or something that looks the same as when you're running a CI job, or when you're doing a salsa build provenance, or when you're packaging something with Debian. And in order to do that, In-toto has something called an In-toto attestation framework, which basically, if you were to look at this, it can be a lot of text, but think about it as like you have a major envelope that basically contains the attestation itself. And then within the attestation, you have something called you have two things, right? You have the subjects and as well as the predicate. So the subjects are basically the things you're attesting to. So if you're attesting to, say, a Debian file, right? That will be the subject. And then you then also have the predicate, which is the evidence. Now, I like to focus a bit more on the predicate side of things, and if you look at this predicate, it is SPDX predicate, so it's attached to an SBOM. Now, SBOMs are not the only thing we can predicate on. You then also have links, which is basically an input-output. And then you also have salsa provenance, which is basically you have build provenance, and then you have all the other salsa tracks that could be of interest. And you also can attest to releases, runtime traces, test results, vulnerabilities, and et cetera. And then if you're curious to learn more about how attestations work, there's a QR code that points to the In-toto attestations repository. Now, basically, one of the things we're trying to say is you can achieve compliance with transparency using In-toto attestations. Now, how do you get started? Right now, we're just going to highlight a few of the tools that you can use right now to basically get started. One of them is In-toto Witness. It is a production-ready implementation of In-toto that you can readily just download and then start generating In-toto attestations. It was developed by folks at TestifySec, and it was donated to the In-toto project last year. And then there's also a repository if you want to look at it. And then how Witness works is basically you have context that you're running Witness on. So that could be your GitHub action, or that could also be like GitLab, CI. And then you basically give it input files, and you have the output files, and it will capture that into a context. And then it will then pull key from, or like a key provider, right? That could be Google or like a cloud provider KVM, and then use that to sign a attestation.
So really what that's doing then is really you take whatever step you'd normally do as part of your software supply chain, and you just capture the things you're doing it on, and rather than have this be something that somebody puts a check mark in on a notebook or inside of a Google spreadsheet or something like that, then now you get this like cryptographically attested thing that's signed, and you can do your compliance and everything automatically. So you don't have to do any of these manual steps anymore, right?
Yes.
Okay, great.
Thanks. And then once you generate it, you then have to store it somewhere. And the next project I'm going to show you is Archivista, which is basically another project that was developed by the folks at TestifySec. It basically helps you store and maintain the relationships between the subjects. So basically, it also has you can start dumping all your attestations into it, and then if you need to, say, extract an attestation that was generated by, say, a specific person or a specific machine, you can get all the attestations. Or if you need an attestation of a specific type, you can then request it from there. Now, with these two tools, you can get a pretty good working relationship, like a good working view of like what's happening in your software supply chain, right? You have all the tools you're using, you have all of the cloud providers that you're utilizing, and all the information that you're generating. But how do you make sense of it? And then now from there, we have something called how you can now visualize and understand your supply chain using something called GUAC, which stands for Graph for Understanding Artifact Composition. And it was basically, you can fit it not only attestations, but also SBOMs, vulnerability information, and much more. And then it will help you map out the relationship between your artifacts so that you can visualize and create for information. Other things you can do with it is basically you can establish relationship between the components, unveil gaps in your supply chain, so you can basically take a look at it and then find where you have any issues or where like a dependency is not set up properly. And then you can also identify threats and then fix it. And then one additional plus is that you can also visualize it. This is an example of like an artifact that has its dependency laid out using the Debian and as well as SBOM, right?
So GUAC's a really useful tool, but it's not essential. If you don't want to use it, you don't have to, but it can help you just get more out of your information because it's easier to visualize.
Yeah.
Yeah, awesome.
Then, and of course, like this is basically a really small example because software supply chains can get very complicated and you can get a really big graph. Now that you have all of that information, right, how do you make sure that your supply chain conforms to a specific standard, or you make sure that you have some internal QA that you want to adhere to? How do you make sure that, how can you leverage all the evidence to enforce that? So one of the things In-toto also could help with is basically validating the development process. So you can answer questions like, hey, is my CI being run on the trusted devices? Is an SBOM gene generated in the end? Is my image getting scanned in the end, or is it getting tested? Or even towards the end, it's like, are there enough people looking at this artifact, right? So you can basically say, hey, I need 2 people to sign off on this specific step. And in order to do that, you can use In-toto to enforce certain policies. We'll revisit the initial supply chain we saw earlier. So pretty straightforward. And let's just focus in on the specific steps. So you currently have 4 steps. You have the source control, you have the test, the build, and then the packaging. Now, each step is run by someone that you should trust. And now, at each step, some steps will have outputs, and these we will call products. So basically, if you're source control, when you're downloading the source repo, you're basically generating the code, and then when you're packaging or building something, you're generating a specific artifact after that. And at each step, you then also have a material, which is basically the input to each step. And from that input, you can then start figuring out like, okay, I want to make sure that the product I'm building is also using the source code that I downloaded. And then you can then start drawing out all of these relationships between each step, and then use those to then draw out and then write down like, okay, what's the shape of my supply chain? And this we'll call a layout, right? An In-toto layout. And how do you make sure that this layout is indeed what you want it to be, or whatever the project owner expects? It will be signed by the project owner. So this is basically a big picture idea of like what an In-toto layout does. This is how you enforce like the certain policies. And basically, if you have the In-toto layout with the attestations from your steps, you can then verify that a specific that your supply chain was not adhered to the specific layout. Now, basically going again over In-toto layouts, basically the main thing that you can do is like define relationships between certain steps, and then the other things you can do is like basically define who is a trusted functionary for each step. Now, one of the issues is that layouts were designed before attestations came into play. So before attestations came in, we had something called links, which were powerful, but were more limited in the amount of data you can contain within it. You first define the inputs of the step, the outputs of the step, and the specific command that was ran. With newer attestations, you have more metadata. For example, like with a salsa build provenance, you can then contain what specific version the specific machine it was run on, and even, I believe, like even the current state of the machine. So that's basically one of the things that we want to take advantage of, and through that, the community figured out like, hey, we have to do something new about. We have to make sure that our policy enforcement catches up to our attestations, and we have the In-toto policy group basically created, and these are some of the things we started working on. So one of our core contributor, Aditya, basically had 2 In-toto enhancements. One of them is to basically help bridge the gap between and enable In-toto layouts to basically leverage attestations. And we have a prototype there called In-toto attestation verifier, and there are efforts towards moving all the features of attestation verifier into a witness, the CLI we mentioned earlier. Now, the other things, some of the other goals of the In-toto policies working group, right, is not only to just create a stopgap to make sure that we can use attestations in layouts, but also figure out like, hey, can we do something better, all right? We want to improve the use cases, improve the usability, improve the way you can define certain policies. And also, is there a way we can do this differently, right? So one of the things we're looking at is like maybe we can talk to other policy engines like Macaroon, and then figure out if we can design something that's like policy engine agnostic. That way, if someone's like, hey, I have this policy, I want to give it to you. I want to make sure that your policy engine can also enforce such a policy. That way, policy can also be shared between individuals and teams. But yeah, that's it for policies, and then we're going to get on to community updates. So this is basically integrations and adoptions. If you've seen this slide last year, I think there's a few more logos up there that might not notice, and there's a few things that are new since last year. So we have GitHub introduced generating of build provenance in GitHub Actions. Homebrew is now supporting, I believe, I'm not familiar with Homebrew, but I think they're generating attestations when you bottle a specific package that you can also look at. You also have PyPI supports package authors uploading attestations. And also there's a white paper that Autodesk and TestifySec released that went over how they achieved FedRAMP, which is level of compliance in the United States using In-toto attestations by leveraging Witness and Archivista. The other thing, update, is that In-toto has finally graduated, all thanks to the work from Justin and the people.
Everyone in the community.
But yeah, so if you're interested to learn more about In-toto, feel free to join us. I have added the QR code with the slides, so if you want a reference to it, you can look at it. And yeah, I mean, one thing I'll also like to add, if you or your company has also implemented In-toto and you have run into certain issues, feel free to talk to us, and we can then understand better like how we can either improve the framework or maybe come up with a way where everyone can share like how they implement In-toto, and hopefully it can grow.
Yeah, we're a big welcoming community, and we'd love to have any help, feedback, thoughts. So yeah, and thank you all for listening to us. Feel free to ask any questions.
So our project publishes the In-toto JSON stuff, but it feels like it's an extra file that needs to get carried around and validated and so forth. Have you looked at all at ways to make that discoverable if I just have an artifact? Because carrying around 2 or 3 or 4 things gets a lot harder than carrying around 1.
Yeah. I mean, that, so if you're coming from a US-based organization, which I'm not saying you are, and most of you are not, then there's already a mandate to do SBOMs. And there's also a lot of push within the EU and elsewhere to mandate SBOMs, and Japan and other countries are also standardizing these formats. One of the efforts we're doing is also to, in a normalized, standardized way, integrate In-toto attestations as a field that's locatable from your SBOM. And so this is one way in which this potentially could be addressed in the, I don't know, fairly short term, like months to maybe a year standpoint if everything goes well. There are other ways and other options and stuff like this that organizations use. Some of them, if they distribute things, for instance, via a TUF repository, then the TUF metadata will contain actual linkages to the in-toto metadata. That's the other very common way to do that, and that's Datadog and lots of other big companies have done that way as well. So there's a menu of, yes, there are different ways, and if you think of another way that we should be promoting, then tell us about it.
Can you share a little bit more about how you think about SigStore and Skit and their relationship to In-toto?
In-toto attestations are one of maybe the most popular thing that's stored inside of SigStore's Recore. It's just like a major driving force. I think we have, I'm going to get this slightly wrong, but it's hundreds of thousands in the last few months of added in-toto attestations. And so we're very happy to be a part of that and really happy that a lot of the organizations that make things want to sign it and use SigStore and other things. So one of the creators of In-toto is a PhD student of mine, Santiago Torres Arraiz, and he's also one of the creators of SigStore. So the projects were always at least thought of as having some relationship and work very well together. I know we went through a lot. If you have a question you feel is like a dumb question, do not hesitate to ask. We went through a lot of things really quickly and so on. So happy to take any questions, or we can always take it offline if anybody's shy. Someone is not shy. Here we go. All right.
Is there a link, or will there be sometimes in the future with the Salsa project and the level of not compliance, but the Salsa levels?
The sensor elements, you mean in terms of when you run?
No, Salsa.
Oh, salsa. Oh, yeah, sorry. So, do you want to talk about that?
No.
Or do you want me to?
Yeah, got it.
All right. So salsa actually first came into the CNCF, or into the Linux Foundation, as a subproject of In-toto. And actually, the format, if you go to the Salsa website and you look at like a Salsa attestation, it's an In-toto attestation. Okay. It's an In-toto attestation that points, in the policy part, points to the Salsa portion of it. So Salsa is like a very, In-toto is doing a very easy part of what Salsa is trying to do, but it's doing a part that gives it like kind of a layer of compatibility, kind of like IP on the internet, like provides this layer of transport everywhere. In-toto is this little signing layer that's in a lot of these technologies you see out there, like almost everything software, supply chain. If you go into it a bit, you find an In-toto attestation wrapper there because a lot of the tooling uses it. And then Salsa has all the opinions about what should it mean for something to be like source track, this level compliant, or to have this build level compliant. It's like it has its own opinions on the boundaries you have to meet, and In-toto, it just takes that data along for the ride. So we love the Salsa community, we work with them, and they're terrific folks.
Thank you.
Sure.
Yeah, I mean, one other thing I would like to add to that is like, if you look at the homebrew repository and all of the attestations they generate, most of them are Salsa attestations, but they're encapsulated inside an In-toto attestation, right? So you can think about Salsa as like via specific contents, and then In-toto as the protocol that it's sent through, right? So I need the way it's shared. So.
Yeah. Sure. Go ahead.
I didn't saw in the layout format and the graphical the graph you showed. There were no, if I'm not mistaken, the information around it was after on the machines and servers that are making the builds, and if they should be compromised,
Yeah,
that will.
that's a great question. Okay, so your in-toto layout contains, it contains keys for the parties that are supposed to do the roles. And those could be things like a key in an HSM on a build server, or it could be some like spiffy or cert manager provisioned identity on some system, or it could be an ephemeral key from SigStore or whatever. It can be anything you want. I got distracted by him dropping his Kleenexes as well. I don't know, he's gone now though. But literally, it doesn't matter what who the functionary is. We can say you have that functionary. Now, imagine something like a compiler. Okay, you're going to take in a source program, maybe that's in C, and you're going to produce a binary out of that that's executable. In-toto can't know that the compiler compiled the thing and did the right thing when it compiled it, right? It can know that it read this file and that it produced this output, and the compiler had this hash to it and everything else. But if your compiler has a bug in it, or if you were supposed to do code review and you just are like, I don't want to look at this, I'm just going to say looks good to me and hit, not that anyone would ever do that. But if someone ever happened to do that in the history of the universe, we're not going to say, oh, you didn't have two people check this, because you did, sort of, right? We can't know that information, but we can make sure it went through your actual policy, and your actual server is the one that ran the compiler, and actually the right version of the compiler, and the compiler produced this output, and so on. And so it provides you a lot of protection, but it can't be foolproof against everything. You have to also, in some cases, worry about the individual steps. Do our developers pay attention when they do code reviews? Are we running a compiler that's, was written by someone in, North Korea and something like that? You have to care about those things a bit.
Did you load a kernel module from North Korea?
Yeah, do you load a kernel module? Don't load a kernel module from North Korea. Pro tip. You heard it here first.
We're out of time.
Yeah, we're out of time, I think. If anyone has any other questions, we're happy to take them. Thank you all so much for coming.
Thank you.